Kublai pi barok bape ikan nika video nyiptiang subai pi share nika channel ka Tech Tutor Meghalaya balapan mi daga SCSTE. Kegerteng jonga kalong iba pediang hun kongwer but hakan nika porpat gan batai pi shapang ke electric field due to an infinitely long straight conductor. Te paranok haka video kepada mila ada discuss ngada pulia shapang ke Gauss law. Day, but hang to ngila yo eka formula haka bangi to phi E is equal to surface integral, alright, of E vector dot ds vector equal q by epsilon naught. Then you E do A, ude U, electric field, ds do A, to surface area. Q is a charge belong to but enclosed within the surface area, and epsilon naught is your permittivity. They using this formula, Phi in M, ladanga find, okay, using this formula, I can find the value of electric field. Alright, so kani ka Gauss law kan, kani ka Gauss law, ka allowing you bangin use kani ka formula, ban find the electric field, alright, ya kani ka electric field ka way ni ki formula hasua ka bangi penankam ka bangi yo ka dinaka Coulomb's law, but kung mga laong ka video bala ada ka Coulomb's law ka ailat ingi ban penankam tanga ka por ba ya day ki point charges, but ba kani ka Gauss law ka ailat ingi ban penankam la day but ki continuous charge distribution rule, and so that's why using this formula, alright, nilalaban find yaka electric field, alright, due to continuous charge distribution. The hakanika case mamenta, or hakanika topic mamenta, in find yaka electric field due to an infinitely long straight conductor. See, ude u conductor ubadrong ha. Alright, kamu matwa uni conductor ude ubadrong ha, badan ki charges. So ude linear charge distribution. Okay. Consider an infinitely long straight conductor whose charge per unit area is lambda. If you still remember that if you don't know lambda do A, linear charge density. The linear charge density definition di kumno gadika charge per unit length. And let P part be any point at the distance R from it. Dimintang android, okay, uni do infinitely long straight conductor janga. Alright. They would positively charge, alright. They would need the infinitely long straight conductor. Dengan should draw dot should draw dot ni siapa ban peni ba uday balong infinite kamano dan jingkudra. Okay, toh. They would need the infinitely long straight conductor jangan, alright. Ha kaba ka linear charge density di kamano linear charge density de lambda. Fine. Lani kata ka charge per unit length string day lambda. Okay. Then in consider a point P. Then let me consider this is my point P hang ni. Alright. That is my point P, and this point P, it is at a distance. Alright. It is at a distance R from the wire. Okay. The symmetry of the charge distribution requires that the electric field E due to the charged conductor be perpendicular to it and directed outwards as shown in the figure. There, kato sentence ko ba ke electric field, okay? Because of these charges, kade in which direction? Kalong perpendicular, alright? Kalong perpendicular to this wire. So it is in this direction, the long perpendicular to the wire, come on, either to the right and also to the left. This is the electric field, alright? The electric field due to this wire, right? Shall left rukadan, shall right rukadan, alright? Throughout the length of the wire. Dengan rotang hati hadrong men representing kata, right? The electric field to the left and to the right. Throughout the length of the wire, electric field kadan, kabadai shall left rukadan, shall right rukadan. Okay, the minta ban find yaka electric field at point P, okay, due to this conductor. Ngin haban penulkam no yaka Gauss law. The ban penulkam yaka Gauss law ke e bengidan kam ning kongsha. Gidan kam yaka Gaussian surface, okay. Namar ba uni wire minta, as you can see, kam donre any kind of closed surface, right? So ngin haban construct hi. The Gaussian surface kabangan use na kabenta a linear charge distribution. Kung mangila ada pulih ha ka previous video, ngan use da cylindrical Gaussian surface. Dengan draw cylinder, alright, saudong ya uni wire jonga in such a way. But uni point P would be done on the surface jong uta cylinder. Okay. Now, if you draw a new cylindrical Gaussian surface, alright, take a length jong new cylinder, and shim kande L, alright, that is the length of the cylinder. And now, there another thing about important kade ba, new axis jong cylinder, kabamod ba uni bana pedeng, alright, jong to cylinder to pedeng jong cylinder would been pass through jong new wire would been yet na pedeng jong cylinder. Okay. They hang ne nga dap draw a Gaussian surface and nga dap consider a length jonika Gaussian surface. They hang to we have constructed a cylinder, alright, a cylindrical Gaussian surface of length L to pass through point P such that the axis of the Gaussian surface coincides with the conductor. Now, thus the Gaussian surface has three regions labeled 1, 2 and 3. Tingin yung label kita ki lightly regions. Take a second region. Can they hang ni? Can they through nagadiga site? Alright. First region, can they the top of the cylinder. Second region, can they link back a side jong cylinder. South down side jong cylinder. Alright. And the third region, but can they the bottom of the cylinder. Fine. They ada lightly regions. Alright. Ki surface area. Ki ba link back ka electric field kalakban pass through. Na top, na bottom kalakban pass, but na side there, okay, saudong jong cylinder, alright. Then now, when you use like a formula, then can you get electric field? The charge enclosed by the Gaussian surface is given by the charge per unit length, alright, which is lambda into the length of the Gaussian surface. This is equal to charge per unit length, de lambda, alright, and length of the Gaussian surface, meaning a shim, can you get length, length L. So lambda into L. That is the total charge. Alright. The charge but enclosed matlab done hapo jang ka Gaussian surface. Okay. And kumangila tho, but the charge enclosed by the surface is represented by a capital Q. Then now from Gauss law, right, nitib the formula ka day, surface integral of E dot ds is equal to 1 by epsilon naught times, alright, the charge enclosed by Gaussian surface, alright, or we can write E dot ds equal 1 by epsilon naught times the charge Q. Then if you but done lightly surface area, alright, three regions hakabak electric field kalaban pass through. Then ngan shim small area ds from all the three regions, alright, hakabangan calculate ka electric field, alright, pass through that area ds, kanamanganya padan kami ka formula. So from this area 1, let me consider maybe an area here, alright, this will be my ds, okay, and according to puli, alright, from the formula of electric flux, but the area happen shim in the form of a vector. So the area vector is always kalong perpendicular to the surface, alright. So therefore the direction of this, alright, of this ds is perpendicular kalong shadrong. Okay, so this area vector point shadrong. Fine. Now, same thing I'm going to do for region 2 and region 3 also. Ngan shim area ds. So for region 2 ngan shim area hang ni habadon ni point P hi. Keep in mind, alright, bahang ni ka derivation journey we are trying to find the electric field through point P. Nagatakadaw ngan haban shim ke area at point P. Okay, so this is my area ds at point P. And again, area vector at point P, alright, ds can point to A, can point outwards. Keep in mind, mabaga ka closed surface, kaya 3D object, ki surface, ki area vectors can point outwards, alright. And lastly, from the bottom, I'll choose this area here, ds, alright, where the area vector points downwards in this case. Timintang la define load kito ki areas, alright, in all the three regions, we have this area, and this area. Alright. Dia minta ngin haban find electric field. Keep in mind electric field ngin haban find ke jong point P. Alright. Then electric field ngin haban find using this formula. Alright. Kadai electric field throughout this cylinder. Okay. You haven't find what is the total electric field through this cylinder. Then now that will be given by the sum over the electric field first over the first region. Electric field over the first region, and they E dot ds, okay, plus the electric field over the second region, E dot ds, plus the electric field over the third region, E dot ds, right, equal to q by epsilon naught. Okay, the minta I'll remove the vectors, alright, and write in terms of scalar along A ds cos of theta. So here theta, alright, is the angle between E and ds in the first region. What is the angle between E, alright, E is pointing that side and ds is pointing up. What is the angle between them? It is 90 degree. So therefore cos 90 degree plus integration over the second region A ds, again cos, what is the angle between the second region? Alright, ds points in that direction, E also points in that direction. What is the angle? The angle is 0, so therefore 0 degree plus integration over the third region. Alright, in the third region the direction of ds is downwards, the direction of E is that side. Okay, so therefore the angle is again 90 degree. So therefore I'll write A ds cos of 90 degree equal, what is the value of q? Q also we have found is equal to lambda into L. So therefore lambda L divided by epsilon naught. Right. So next line, what is cos of 90 degree? Cos of 90 degree is equal to 0. So therefore this product here, this whole thing becomes 0. Okay, so the next term, what is cos of 0 degree? Cos of 0 degree is equal to 1. So therefore the term can remain integration, alright, A ds into 1, which is EDS. Alright, the third term, look at the third term again, it is cos 90 biang. The cos 90 kadikat no kadai 0. So therefore this term also kaja not number, but anything to 0 is 0. So I will not write anything anymore. There lastly, it equal lambda L divided by epsilon naught. You meet lambda L divided by epsilon naught. Yeah, integrate, alright, E hangye is a constant. I'll take it outside of the integration side. So integration over the second region, ds is equal to lambda L divided by epsilon naught. Take ds over the second region. Shape to the second region. The second region, as you can see, kaditang kanika curved surface area. And what is the formula of curved surface area of a cylinder? Kadai 2 pi r L. Alright, so therefore integration of ds come with integration of this entire curved surface area, alright, which is 2 pi r L, is equal to lambda L divided by epsilon naught. Therefore E is equal to lambda L divided by 2 pi r L epsilon naught, but hangni nilaban E bau L, but L nilaban cancel. E is equal to lambda divided by 2 pi r epsilon naught. The formula, alright, yung electric field due to an infinitely long straight. So it's can plus to derivation. Yung electric field due to an infinitely long straight conductor. Tingin sa siyampat, hakaway video hakabangan patay pat sa siyapang electric field due to an infinite plane sheet. Kublish mo.